Second task is related to power electronic and load flow. Subtask A is related to power electronic circuit. We have to analyze this circuit. Subtask B is regarding fax device, STATCOM, GCSC, and finally a load flow calculation. In order to evaluate a power electronic circuit, in order to evaluate this circuit, you need some background related to diode. What's the diode? Diode is a two-layer PN semiconductor device, and it's an ideal diode. You can see it's an electrical one-way valve, and there are two terminals. This terminal is called anode. This one is called cathode. So, and this one is the idealized characteristic. You can see sometime the current is infinity. It means that it is bypass or short circuit, or sometime it's zero. So it is one way. In one way, it can carry the current. If a positive voltage or the most positive voltage in the circuit is applied to this terminal, it can carry the current. The diode is on and the forward current through it. And when the voltage across the diode is negative, it means that the voltage here is negative. So there is no current. So it's switch off. Consider as a switch on and off. When it's on, we say that there is a short circuit, and when this is negative voltage on anode terminal, we can say that the switch is off. You can see the characteristic here better. For example, here it's the main circuit. The voltage, the positive voltage terminal goes toward the anode terminal. And if this one is positive, so the circuit is short circuit. The diode is short circuit. However, suppose that this one is negative. This voltage is negative. It means that this terminal has higher voltage compared to this terminal. So it will be switch off. With this background, and another thing related to thyristor, because you have thyristor as well in your power electronic circuit. You can see here it consists of diode and the thyristor, and you have to know that what's the basic performance of diode and thyristor. Thyristor is a bit different. In that way, we have 3 terminals instead of 2 terminals. Anode, cathode, and the gate. Gate is another things that provide the control capability for thyristor. In order to carry the forward current, it must be turned on or triggered by injecting a small current into the gate. So something are similar to the diode. If the voltage applied to anode terminal is positive, the thyristor has the capability to be turned on. However, it will wait until the triggering signal from the gate terminal. It's the difference, the triggering that create control capability for us compared to the diode. Once it's turned on, thyristor will continue the current as long as there is a positive current to carry. And if the current goes to 0, the thyristor has a reserve voltage and it will be turned off. So with this background, we want to evaluate this power electronic circuit. And this one is input, Vs here. So the input signal, suppose that I want to evaluate the circuit just in one cycle, from here to here, okay? One cycle consists of 2 parts, the negative side and the positive side. Since positive evaluation is more simple, I will start with this one. The positive voltage, the input voltage, you can see consists of two parts as well. From this point, pi, pi plus alpha. And then from alpha till 2 pi. So we can divide into subsection. For the first section, from here till alpha, you can see this the equivalent of power electronic circuit based of being turn off or turn on. You can see here the voltage is positive. The input voltage is positive. The input voltage will go toward the anode terminal of this diode. So it will be turned on. However, this part was the most positive voltage in the circuit, and this terminal will be the most negative voltage in the circuit. When the most negative connected to the cathode terminal, it should be on if it was diode. However, since it is thyristor, it will wait to get the triggering signal from the gate. So during this part, before alpha, we don't have any signal from the gate. So thyristor is off. You can see only the diode D1 is on. And if you evaluate this system, you can see here, this is short circuit. Here, there is no closed loop in the circuit. So you will not have any current. You have voltage, but there is no current. Input voltage we have, but since there is no closed loop, the output voltage will be zero. The output current will be zero because you cannot create a closed path for the current. And the input current will be zero as well. However, for the another part, from alpha to 2 pi, we know that since it's positive, the voltage of input is positive. This diode will be on. The thyristor, this one will be on because after alpha, the thyristor will get a triggering pulse from the gate. Then the thyristor will be on. So these two switch will be on. In this way, we have a closed path in the circuit, if you follow the pointer. Okay, you can see the input voltage. This terminal is connected directly to the positive side of voltage, output voltage. And the negative goes directly to the negative side. So we can say the output voltage is similar to input voltage, Vs. How output currents, what's the output current? We know that the output current, this current is output voltage divided by the resistance, Vs over R. And the input current, the current here, you can see, if you consider this one as an input, it goes in direction to the output current. So we have the same direction as output. So we can say input equal to output. However, if the input voltage is negative, it consists of two parts, from 0 to alpha. In this condition, here, it's the positive and negative side of input voltage. Here, this one is negative. It means that the positive terminal is most negative. So the negative terminal will be most positive. So the most positive goes to this point, the anode terminal of the diode. So it will be turned on. On the opposite side, this should be on as well. However, it's the thyristor. It will it will need a triggering signal. However, during this period from 0 to alpha, there is no triggering signal. So it will be turned off. And if you follow this direction, so there is no close pass. The only close switch is this one. Since we don't have any close pass in the circuit, the output voltage and output current will be zero. And since we don't have any current, the input current is zero as well. However, from alpha till pi, this diode is on. This thyristor will be on after alpha to pi. So now we have a close pass in the circuit. And now you can calculate what's the output voltage. You can see this voltage, if you follow the pointer, the positive side of voltage goes this way and goes toward the negative side of output voltage. So that's why output voltage is negative of input voltage. And output current, this one, is output voltage divided by the resistance. And the input current, suppose that this direction is input. Suppose that this direction is the input. And this one is output. Okay? So let's to follow. This is the input. If we have a current in this way, goes to this way, here, 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 and the opposite side of output. So it means that the input and output currents are in different directions. That's why I wrote in this way, negative of current output. So now we evaluated the circuit in different condition. Okay, and suppose that it was the input voltage, okay? So what was the output voltage? You have to draw the output voltage in different condition. We started from here, 0 till alpha. The output voltage is 0. And then here, the output voltage is minus the input voltage. This is the input voltage. Its negative of input voltage will be this one. And during this time interval, here, the output voltage is 0. And then finally, the last one, the output voltage is the Vs. So from here, during this time interval, the output voltage is Vs. This is Vs, and we have Vs. The output current. The output current, firstly, it's 0. Then output current minus Vs over R. Minus Vs. Vs is this one, and it's negative. If we make it negative, this one will be negative Vs over R. And then I out is 0. And finally, I out is Vs over R. Vs is this one, Vs over R. And last part is input current. We started from here. Input, firstly, it's 0. Then input is negative of output current. This one is output current, and its negative will be this one. Then here, the input current is 0. Input current is 0. And finally, input current similar to output. it was output current, so input current the same. In this way, you can calculate the output voltage, output current, and input current. Another subtask in task 2 is related to the fax device. So you have two devices, STATCOM and GCSC, and you want to evaluate its performance. Okay, in order to evaluate them, you need some background about the STATCOM. The aim of a STATCOM is to produce a variable reactive shunt impedance. The main goal of the fax device to bring the controllability to the power system with the semiconductor. So the possibility of generating controllable reactive power directly without using the capacitor, the big capacitor or reactor, or various switching power converter. These converters are operated as voltage and current source, and they produce reactive power essentially without reactive energy storage component. Because of the similarity with the rotating synchronous generator, they are termed static synchronous generator. In GCSC, GTO thyristor control series capacitor. GTO, it means gate turn off thyristor. I said that before, thyristor, we have control on turning on, but we didn't have control on turning off. With more flexibility, we have another semiconductor that is called GTO. You can see this one is GTO. With the G2 parallel GTO and the capacity and the capacitor, we have the variable capacitor. The object that this one is called GCSC. The object of GCSC is to control the AC voltage. We want to control this voltage across the capacitor. And after many calculation, you can find this formula. The reactance of the whole system will be this value. And this gamma is under our control. So we can say with GCSC, we can control the reactance of the whole device. We have a variable capacitor. Okay, we'll back on task 2. About the performance of STATCOM. You can see this one is a STATCOM. There are two sides, the DC side and the AC side. The DC side is small capacitor. We have converter here that converts DC voltage to AC voltage and then connected to a transmission line. A STATCOM will be connected to the transmission line in parallel, that we call it shunt device. Each output voltage, the voltage that we want to create here, will be in phase to this voltage because we don't want to insert or observe the active power. But varying the amplitude of the output voltage here, the reactive power exchange between the converter and the AC system will be controlled. We want to use this basic idea. When you have a transmission line, and suppose that you have voltage V1, the amplitude and angle, delta 1, V2, amplitude and angle, delta 2. You know that if you want to control active power, you have to play with this delta. We know that active power exchange between 2 points is proportional to the angle difference, delta 1 minus delta 2. Okay, and the reactive power proportional to amplitude of voltage, amplitude of voltage on both sides. So suppose that if you build a voltage that its amplitude is bigger than this voltage, you can generate reactive power. So you can send reactive power. If in this way, V0 is bigger than V, the amplitude. However, if you want to absorb the reactive power, if V0 is smaller than V, this one can absorb reactive power. So with controlling this V0, we can control the reactive power. And the GCSC, we know that the objective of GCSC is control the AC voltage. The GCSC wants to control this voltage, VC, across the capacitor to have a variable capacitor. The magnitude of the fundamental component of capacitor can be varied continuously by controlling a turn of delay angle. I showed you before, this one. With this gamma, you can control the reactance of the whole system. It's possible with GCSC. And you know that if this one active power, V1, V2 over X. Okay, so if we can manipulate this reactance, we can manipulate active power. So you had this before. Suppose that without compensation, K is 0, you have the usual curve, active power in terms of delta. However, if you can manipulate this X with the GCSC, you can change the peak of this curve. So in this way, GCSC can control the active power.